Example numero dos in Notes for Algebra 7-4, writing and graphing exponentials. So example 2 is asking us, is the following relationship a linear function? So immediately, whenever you're seeing the word linear, the constant rate of change wants to be floating through your head. And that is going to be what you use to explain your answer when you do so. And then create an equation to model the relationship. So we need to decide first if it's linear or not. So just a little brief reminder that your inputs are your x values, aka your domains. Your outputs are your y values, aka your range. A little bit of function vocab from Unit 5 up in there coming at you. Like, whoa! Okay, so if I'm looking at the inputs first, I can see that each one of these inputs is going up by 1 each time, right? I have +1, I don't want red anymore, I want green. +1, +1, +1, +1. So that's cool. So I really just need to focus on the y values and what's going on with them. So to go from 10 to 30, I need to add 20. To go from 30 to 90, I would need to add 60. To go from 90 to 270, I'm going to need to add, I believe, 180. I'm getting a little past my confidence here in terms of, pretty sure that's right, because 270 is, yep. So then we're going from 270 to get to 810, and that is by 540. So right away, based on that purple stuff that I just did, this is not a linear function. The table does not show a linear function because there is not a constant rate of change. Really important, you don't have to do change in y over change in x if you show me this pieces right here. This right here is enough to show me that it's not a constant rate of change because you're showing me that it's going up by a different amount each time. But you do need to have some sort of a work. If you just write it, there's not a constant rate of change and you don't have any proof, you're going to lose some points on that. Okay, so then we know that this is going to be, if we look at the other direction, the other way I can get from 10 to 30 would be by multiplying by 3. So 30 to 90 times 3, 90 to 270, 270 to 8 timesing by 3. That tells me that this is an exponential relationship. Just because we're multiplying by 3 each time, that's not a constant rate of change. Constant rate of change has to be the adding or subtracting. This is an exponential relationship because it has that multiplying factor. It has a multiplying factor of 3. So then, to make that equation like it asked me to, y equals a times b to the x powered, just like we wrote at the top of our notes. The sooner you memorize that, the happier you will be in your life, in your math life at least. I can't make any promises. So remember that a is my y-intercept, which is actually right here with that 0, 10. So I'm going to fill that in. Y equals 10 times my multiplying factor, like we already talked about, is that 3 times 3. It's tripling each time. And then that x is going to stay as the exponent. Boom, soft.